Ever wondered how your phone can instantly recognize your face, or how a self-driving car can tell the difference between a pedestrian and a stop sign? It might seem like magic, but the secret lies in a fascinating field of artificial intelligence called neural networks. Today, we're diving deep into what neural networks are and how they power one of their most impressive abilities: image classification. So if you're ready to peel back the layers of AI, let's get started. At its core, a neural network is a computational model inspired by the human brain. Imagine a vast interconnected web of tiny processing units called neurons. These neurons are organized into layers: an input layer that receives information, one or more hidden layers where the real thinking happens, and an output layer that delivers the final result. When data enters the input layer, each neuron processes it and passes its signal onto the neurons in the next layer. The connections between these neurons have different strengths, or weights, which are adjusted as the network learns. Think of it like a team of experts, each one specializing in a tiny piece of a puzzle and collaborating to solve it. So how does this apply to telling a cat from a dog? This is where image classification comes in. When you show an image to a neural network, it doesn't see a cat. Instead, it sees a grid of pixels, each with a specific color value. These pixel values are fed into the input layer. The first hidden layer might learn to recognize simple features like edges and corners. The next layer might combine these edges to identify more complex shapes like ears, eyes, or whiskers. As the information moves through the network, each subsequent layer builds upon the last, recognizing increasingly abstract and sophisticated patterns until the final output layer can make a highly accurate prediction: cat or dog. But a neural network isn't born smart. It has to be trained. And this process is crucial. To teach a network to classify images, we feed it a massive dataset containing thousands, or even millions, of labeled pictures. For every image of a cat, it's told, "This is a cat." Initially, its guesses will be random and mostly wrong. But with each guess, it compares its answer to the correct label and adjusts the weights of its internal connections to reduce the error. This is a process called backpropagation. Over countless iterations, the network fine-tunes itself, gradually improving its accuracy. The quality and diversity of this training data are paramount. The more varied and well-labeled the examples, the smarter and more reliable the network becomes. And there you have it, a glimpse into the world of neural networks and image classification. We've seen how these brain-inspired systems are built from layers of interconnected neurons, how they learn to see by recognizing patterns from pixels, and how a rigorous training process allows them to make incredibly accurate predictions. From simple photo tagging to complex medical diagnostics, this technology is already reshaping our world in profound ways. What was once the stuff of science fiction is now a fundamental tool driving innovation forward. Thanks for joining me on this journey into the mind of the machine.